Computing systems. All computing systems require both hardware and software in order to function. We'll define hardware and software with the following. Hardware includes the physical, tangible parts of the computer, and software executes or runs programs and data. We'll review all of the necessary hardware components in a computing system, like the power supply, motherboard, the central processing unit or CPU, memory, graphics cards, and peripherals, internal and external. The power supply is the device that supplies power to all of the components in a computer. Within the power supply, there is a transformer, voltage control, and fan. The transformer is used to convert the alternating current that is received by the power supply from the outlet into direct current, which is what is needed by all of the hardware components in the system. A motherboard is the central circuit board in a computer. It provides the electrical connections by which all components in the system communicate. The motherboard has many ports and slots that are used to connect what are known as peripheral components to the main circuit board of the system. Peripheral components expand the computer's capabilities. Depending on the type of computing system, some of these peripherals are incorporated into the motherboard. A few examples of components that may be built in or connected to the motherboard are CPU, graphics cards, RAM, and hard drive. If a central processing unit or CPU is not built into a motherboard, then there's always a specific port meant to connect the CPU to the other components in the system. The CPU is the processor of the computing system that executes all of the computer programs. When executing the computer programs, the CPU is using a four-step process: fetch, decode, execute, and write back. The fetch-execute cycle is the basic operation of a computer. During this cycle, the computer retrieves, decodes, and runs a program instruction from its memory. The computer's CPU continually repeats this cycle when it is turned on. Fetch involves retrieving an instruction to run a program from computer memory. When decoding, the instructions are broken down and dispersed throughout the CPU. After the instructions are broken down and dispersed, they are executed around various parts of the CPU to perform the desired operation. Once the commands are executed, the CPU uses the write back step to output the results. A processor register is a quickly accessible location available to a computer's processor. Registers are normally measured by the number of bits they can hold. For example, an 8-bit register, 32-bit register, or 64-bit register. Processor registers are normally at the top of the memory hierarchy and provide the fastest way to access data. Some types of registers include data registers, which hold numeric data values, address registers, which hold addresses, and general-purpose registers, which can store both data and addresses. A memory address is a reference to a specific memory location in a computing system. Addresses are sequences of numbers. Each memory location has a physical address, which is a code. A bus, also called a data highway, is a communication system that transfers data between the components inside a computer. Different types of computing systems require and use different types of memory storage. Random access memory, or RAM, is a form of computer memory housed in an integrated circuit chip. In a stick of RAM, there are memory cells made up of transistors and capacitors that store data in bits. If you know the row and column of a cell, you can access the data stored in that cell at random. There are slots on a motherboard designed to hold RAM. The number of slots and each slot's capacity determines how much RAM storage a system will have. A downside of random access memory is that all data stored is lost when power is lost. Hard drives are used to store information when there isn't any power. Hard drives can come in the form of hard disk drives and solid-state drives. These two types of storage devices vary in the way that information is stored. A hard disk drive uses rotating magnetic disks to store and retrieve information from memory. A solid-state drive uses integrated circuit assemblies to store data using flash memory. Hard drives, no matter which form, can be found internally or externally in a computing system. A graphics card displays quality images on the computer screen for playing computer games. A graphics card looks like a smaller version of the computer motherboard. It's a circuit board that has a processor, RAM, and other components. A graphics card is sometimes commonly referred to as a graphics processing unit, or GPU, but in reality, the GPU is just a component of the graphics card. Computer peripherals expand a computer's capabilities. Peripherals allow a computer to perform more functions than would be possible without the peripherals. A few examples of peripherals are graphics cards, monitors, a computer mouse, keyboards, and printers. Peripherals will be discussed in detail later in this unit. The operating system in any computing system is critical for a number of reasons. The type of computing system may change some of the overall tasks of its operating system, but overall, the common functions of an operating system are providing the interface between the user and the computer, handling the transfer of programs from memory, organizing the use of memory and processing time between programs, and maintaining security and access rights of users. Now that we've discussed the main hardware and software components in any computing system, we'll review the variety of systems. There are three main types of computing systems that we'll review: desktop systems, mobile systems, and cluster computing systems. Desktop computing involves working with a computer that is not portable. Examples of devices that would be included in a desktop computing system would be a PC or Apple desktop computer. These devices are very powerful, and in order to work to their full capabilities, they must always have a wired connection to a network and to power. Mobile computing devices such as laptops, tablets, or cell phones are very convenient devices, since they allow access to the internet no matter where you are, and use much less power. Mobile devices cannot run advanced software applications like desktop devices can, but do offer internet and communication access, which many users like. When working with cluster computing, multiple computers are connected by a common task. Each computer within the cluster receives a portion of the task, and that machine is responsible for analyzing and executing that task. Multiple computers form the cluster in this type of computing. When there are large tasks that would take an unwieldy and inefficient amount of time for one machine to complete, cluster computing is used. Having an increased amount of processing power and memory is an advantage to cluster computing. When determining which type of computing system is the best one to use, there are a few criteria that should be considered. What is the task? How much processing power is needed for the task? What types of applications are needed to perform the task? And how much memory storage is needed to accomplish the task? Embedded systems are a type of computing system that are slightly different than desktop, mobile, and cluster computing systems. Embedded systems, like the name suggests, are attached to something else. This type of system has hardware components as well as application software that is specifically designed to run the hardware. An embedded system is uniquely designed to perform one type of operation based on its hardware and software. Most embedded systems react and respond in real time to an external stimulus. This means that there are sensor hardware incorporated into an embedded system that are constantly scanning for input data, analyzing the information, and making adjustments to its system. Since embedded systems perform one specific function, they must be a part of a much larger network. Embedded computing systems can be seen in a variety of everyday items. In vehicles, ABS braking systems, car alarms, and engine sensors and systems are made up of embedded systems that are designed for stopping a vehicle, sensing an unauthorized entrance to a vehicle, and malfunctions in an engine. Traditional digital watches that are designed to include a timer and stop clock function, and electronic graphing calculating to assist in advanced mathematical problems are all examples of embedded systems. The Internet of Things, or IoT, plays a large role in connecting many devices. The Internet of Things is a network of connected devices that all connect to the Internet. The main distinction between a traditional embedded system and the Internet of Things is the ability for the system to connect to the Internet. Consider all of the smart devices that exist, from smart outlets, smart refrigerators, smart vacuums, and all other embedded systems that are connected to the Internet. The Internet of Things is a system that describes all of the devices connected to the Internet. The Internet of Things can be far more complex than an embedded system, as the embedded systems within the Internet of Things have a shared network that reaches far beyond one device's hardware and software system.